How's it? GP, my self-report. I'm going to do this video to explain how I understand how a foil works. You have plenty of videos on YouTube that explain you how a foil works based on laws of physics, high pressure, low pressure, Bernoulli, but this is a simpler way to look at it, I think, because it's visual. So I got a F1 Phantom S740 here. It doesn't matter, it applies to any foil. So usually you have front wing and a fuse and a stabilizer. So let's look at the front foil first. Well, first, the foil has an angle already compared to the fuse. It's never parallel to the fuse. It's got a little bit of angle going up. I don't know if it's never is. Maybe some raised foils are. I have no idea, but most foils in the market. Already the angle going up will generate lift, but I'll explain why. But that's not the only reason. It's also the profile. You probably noticed the top surface is more curved than the bottom surface. This is a fairly simple profile compared to the extremely sophisticated profiles I'm seeing around now, so it's easier for me to talk about this. So you can imagine when this thing moves through the water, because you caught a wave, you're winging, or you've been told it doesn't matter. If you move through the water will wrap around the top and the bottom and gets released at the trailing edge with an angle. In this case, the angle will be towards the bottom of the ocean. And when you deflect the water towards one direction, you get an equivalent or a reaction force that is on the opposite side. In other words, this wants to go up. That is the lift. Now, just imagine, I do a little digression. If I could, well, on most foils you cannot change this angle or the thickness, of course, it's what it is. But imagine you could magically make it thicker. The water has to go over a higher mountain, that's more drag, and then come downhill the same higher mountain, so it will go down at a higher angle. That means the thicker foil, if you don't change anything, you just increase the thickness at the top, will give you more lift at the expense of more drag. I have not found an exception to the equation more lift equals more drag. If you do, please let me know, but I don't think there are. So imagine the first Go foils, the Evo, the Maliko 200. Those were excellent foils for learning because they were thick and they allowed all of us to learn. But then we all got better, and now the foils on the market, at least not the beginner ones, are much thinner. But that's the same concept. Let's move on all the way to the tail, because the tail also has a profile, but is exactly the opposite of the front. So the top is more flat, the bottom is more curved, and as a result, when this thing moves through the water, it deflects the water up this way, up towards the surface of the water. That means that the whole thing is pushed down, but because they are connected, look what happens. So the tail contributes to the overall lift of the whole system. But that's not the only thing that the tail does, meaning you could do the same experiment. You could do a thicker one and you get more lift and more drag. Actually with the tail you can also change the angle of incidence. So if you make it more looking towards the water by adding a shim at the tail, in this case, then you get more lift and more drag. You also have an effect of stabilization. Why does that work? That's a little more complicated to explain, but you can imagine that if you have something at the back pushing in the water, that stabilizes everything. Let me try to use a Hawaiian canoe example. Let's say I'm on a canoe, I'm the steering guy, and there's either 1 or 6 men in front, whatever, doesn't matter. If I push my paddle in the water generating drag, the whole thing will be slower but also more stable. Also, the more I extend myself to the back and stick the paddle more to the back, the more that effect happens. And that is the equivalent of choosing a longer fuse. Every time you choose a longer fuse, you get better pitch stabilization. You should have a little more lift in general overall because it's a longer leverage. But what really counts, not what really counts. Another effect that I always notice is go slower because it's more wetted area. So get this pill there. The more stuff you put in the water, the slower you're going to go. Another example here, we're talking about pitch stabilization. If I had the same exact foil and I would magically increase the chord from here to here, the foil would be intrinsically more pitch stable. Because the pitch angle, changing the pitch means making this go up and down. Mostly the front foil go up and down through the water. So if this was all the way here, there's more surface that resists that change. So long chord foils are usually pitch stable. I'm thinking Armstrong HS 1550, for example, which is a wonderful foil I owned for many years, and it was super easy. You want to learn how to maneuver on that, that's perfection. Many other like that. But what do you pay? You pay also the speed. A long chord means that the water has to travel along a surface for a longer time, and this is all friction, it's all drag. So the newer, higher aspect foils are instead shorter chords and more wingspan, and they are usually faster and more efficient, but they will definitely be more pitch unstable than longer chord foils. So you might need to use the proper length fuse or proper size and angle in the tail. Well, as you can see, there are so many little variables you can change in order to change the behavior of your foil. And you might be one of those persons that never want to change anything. One foil, always the same, that is totally fine. But if you want to learn how the foil works and what you like in what conditions, you got to start changing things around. The tuning game for me is half of the fun, literally. I rarely go in the water for 2 consecutive sessions with the same gear. I always try to change something, change the tail, change the angles, whatever's, because that's how I learn. So that is the end, I think, of the first video. Cheers. I don't know if you like it. Maybe let me know if you like it, because I'm thinking about doing more, but I'm not sure. I don't have much time. I'm out of the water for an infection these days on a cut. That's why I'm doing it. But yeah, try to motivate me.
Good luck.